All right, welcome back to college algebra. Let's see how we're going to take care of some zeros of polynomials today. So there's a little bit of a walkthrough to our homework, and what we're going to do is just kind of go through it and see what we got. All right, so this one, this is find the zeros of the function and state the multiplicities. Okay, looks like something we got to factor. Okay, so let's try. Mostly, I'm just going to go with our, pairings, the usual pairing. So at least that's the one I'm going to try first. If that doesn't work, I'll try my next thing in the list, and we'll see how far we go. All right. So the first idea here is let's group them and factor those two groups. Okay. So if I look at the first two, right, it looks like an x squared is common to both. What do we have left? We have an x plus 3. These are both divisible by 4, so why don't we go ahead and do a 4? They're both negative as well, so we're going to have x. That sign is going to change. 12 divided by 4 is 3. Hey, look at that. So we have x plus 3, and we have x squared minus 4. It's nice to give us a nice gentle introduction to this. X plus 3, x minus 2, x plus 2. All right. So what are my zeros? So what we're going to do, I suspect you really don't need me to write this one out for you. I mean, this one is easy enough that we could probably see it, but just in case, right? Just in case. Maybe somebody's having a little bit of, they haven't done this in a while and they need some time to warm up. So, but, x equals -3, x equals -2, x equals 2. Those are our 3 zeros. So the zeros, right, are -3, -2, and positive 2. What are their multiplicities? Well, technically, right, each of those is raised to the first power. So the multiplicity is 1, 1, and 1. Okay, so they're all multiplicity 1. So let's go ahead and type that in, see where it gets us. So zeros of h, -3, comma, -2, comma, 2. Okay, I'm hoping that they don't have to do, they didn't say anything about ordered pairs here. So I think they just want this. Right, we'll find out. And then they're going to ask us what the multiplicities are. Well, in this case, it's 1, 1, and 1. And so not so bad, right? It's a nice first problem to warm us up. Okay, what about the next one? All right. So this one looks a little bit more complicated, all right? So let's go ahead. We've got a negative 15x cubed plus 51x squared plus 36x. We have to find the zeros. Okay, so the first thing I'm looking at is that each of these is divisible by 3, and there's an x in each one. Why don't we go ahead and make that smaller by just that little observation? So we're going to have -3, all right? I never like it when the first term is negative. I always like when the first term is positive. So if I can arrange it to where it's easier for me, I'm going to do that. -3x. Okay. So 15 over 3, 15 divided by 3, right? That's going to be 5x squared. 3 goes into 51. It's not going to be quite 20 times, but just 1. That's 3, that's 21, 17 times. So we're going to have a change the sign because I took the -3 out, so it's going to change that sign. -3, -17 rather, x, because one of the x's came out. And then what happens to the 36? That looks like it's going to be 12. Okay, so we have -3x, and now we've got this mess. All right, back when I went to high school, teachers would give us problems like this, and that really meant that they had a free period for a while because it would take you a while, 20 minutes, 30 minutes to do one of these things because it's like the only method we had was like guess and check. Thanks. Now we have something called the AC method. We're going to take the first and the last number and multiply them together. So 5 times -12 is -60. Okay. And now what we have to do is we have to look at all of the multiples of this until we find out which of these two multiples add up to 17. Okay. So what we're going to do is there's a couple of different ways of doing this. I know that 60, right, that's 6 times 10. 6 is 2 times 3. 10 is 2 times 5. Okay, so we have 1 and 60. 2. If I make a 2 here, right, what do I have left? Well, we have 15 times 2 is 30. Okay, we'll pull 3. Okay, so if I pull a 3 out of here, we have 5 times 4, which is, right, 20. I'm looking at this one here, right? Their difference is 17. Okay. The other ones I could have, right, are 4, because 4 and 15 would also make 60. Right, so I pull both of the 4s out. Right, what's left? We have 6 times 10, or we have 5. Sorry, we have 5 times 12. That also makes 17. So that's a possibility, but they have to add up to it. And since we have differences of signs, where I'm looking for things that minus to 17 rather than things that add to 17. Okay. But we have 5 times 12, and then we have 6 times 10. Right, and I think that's as big as we can get going up the scale here. 7 doesn't work. 8 doesn't work. We only have 2 2s. 9 doesn't work. We only have 1 3. And then we have 10, but that just turns us around. Okay, so I'm kind of liking 3 and 20. Okay, so we have 5x squared. How about we do minus 20x plus 3x minus 12? Okay, so all we're doing is replacing 17 with 20 and 3. Right, minus 20 plus 3 adds up to that. There is no, there's no reason as to why I wrote them the way I did. It's just that I tend to want to group like with like. 20 was a multiple of 5, so I put it there. 3 was a multiple of 12, so I put it there. That's the only thing that is guiding the order I'm putting this in. If you wanted to put 3 here and negative 20 here, then you go right ahead. But for me, I like to group them as much as I can. Okay, so we have negative 3x. We've got a 5x. What do we have left? We have an x minus 4. Okay, and then plus 3. And what do we have left here? Right, we have an x minus 4. Hey, what do you know? Now, this is an important topic. This is an important spot. You really do need to check to make sure those are going to be the same thing, right? So if you had tried this with 5 and 12, right, we would get opposite signs here, okay, and it wouldn't work out. So even though I'm looking at this and I'm very cavalierly saying like, hey, this will work out for us, I really am actually inspecting it to make sure it actually works. The 3x, the negative 4's come out. So x minus 4's, and what do we have left? We have 5x plus 3. Okay, now we're going to set the 0 and solve. Okay, so we have negative 3x, x minus 4, 5x plus 3, set it equal to 0. Solve it. So we have 3x is equal to 0. I think we could safely say x is 0. We have x minus 4 equals 0. We can safely say x equals 4. And we have 5x plus 3 equals 0. Now you might take another step in here. We might need a 5x equals negative 3 and x equals negative 3 over 5. Okay, and that's fine. If you see this and say, oh, it's negative 3/5, that's fine. If you need that extra step, that's fine too. All right, you work at what you're comfortable with. All right, so those were our zeros. How many times did each one of them happen, right? We had a multiplicity of 1 here, so we'll look at the multiplicities. It's 1. This one is 1. This one is 1. Okay, so we'll go ahead and answer our question here. Zeros of, it's d of x. Okay, so what do we have? We had negative 3/5, 0, and 4. So negative 3 over 5, 0, and 4. All right, let's check that. That's great. And then each one of them had a multiplicity of 1. All right. That looks like we're good to go. Let's try the next one. All right. See, this one is nice. They factored it for us. We don't have to do any of this. All right. This is, by the way, I like problem number 6. I like problems that make you go through and do all of that stuff. So let's see here. We have 2x to the 4th, x plus 2 cubed, x minus 1. Okay. So we have to solve the zeros. I'm going to do this by inspection. That's when you say to your teacher, like, the problem is too easy. You say, I solved by inspection. I looked at it. The answer presented itself. Okay. So here are my zeros, right? And all I did was just kind of go through the previous steps in my head. And now we have to write down the multiplicities. Well, how many times did this happen? 4 times. How many times did this happen? 3 times. How many times did this happen? Just the one. Okay. So my zeros here, okay, are -2. And what was it? 3? 1. Okay. Check. All right. And then we have to put down the multiplicity. So this happened 4 times. Right? This happened 3 times. And this happened just 1 time. Okay. 4, 3, 1. Good. All right. And that's all they wanted. All right. This one. Hopefully they're getting, yeah, they are. They're getting a little bit, this one's a little tricky. Okay. So we have x to the 5th minus 2x cubed. Let's go ahead and factor that. So we're going to pull out an x cubed. We have an x squared minus 2. Okay. Now technically, right, this is a difference of 2 squares. Like, I don't know if 2 is a square. It is to the square root of 2. So we have x cubed. We have x minus root 2 and x plus root 2. Okay. Both of these have a multiplicity of 1. So by inspection, we're going to say, well, my zeros, right? X equals 0. Okay. X equals square root of 2. X equals negative root 2. Okay. And again, if you have to break these apart and do that, then you go right ahead and do it. Okay. What's their multiplicities? Oh, this happened 3 times, right? There's an x to the 3. So technically, if I was really doing this all the way out, right, we would say this is x times x times x times the rest of the stuff. And then when we do our zero fraction principle, we get x equals 0, or x equals 0, or x equals 0. That's what I mean when I say it happened 3 times. It's because if we were to write all of this out in absolute disgusting detail, right, we could have this. So this happened 3 times. This happened once, this happened once. Okay. So let's go ahead and take a look. So we have, see, they have a square root first sitting right there. So we have negative square root of 2. Oops, I want to go outside, that's the arrow key. I don't want to put a 0 in there. And then positive square root of 2. I'm just trying to put them in order. It's not going to care. If you put 0, 2, and negative root 2, the program is not going to yell at you. I mean, it might warn you. It's like, you should put these in order. But, you know, they typically put them in order. That's why I'm doing it that way. There is absolutely nothing wrong with putting them in whatever order you find. Okay. 0 has a multiplicity of 3. Square root of 2 has a multiplicity of 1. And negative root 2 has a multiplicity of 1. And that is that going to be for this section. Okay, so that's a little walkthrough for this one. I don't know if you guys are actually going to need this one, so maybe just use it to kind of check. But you know, maybe seeing 1 or 2 will really help you do the rest of them. And if you're really struggling, then I'm glad I did them all. Okay, so that you have something to look at. All right, so we're going to go over how to graph them next time, and that'll be in the next video, and I will see you there. Okay, take care.